All right, so what we have been doing before, I'm on page 14 of the chapter 6 handout. What we've been doing is finding delta H. So that's, we're doing the enthalpy of a reaction. And so what we're having to do is we're having to manipulate some reactions from a series of steps to create an overall reaction and trying to cancel. So right now I have a pen, and I'm going to try to do this, but I'm not always the best at it. All right, so let's see here. Wait, this is our example. We have, this is our target. This is what we want to find. This is what we want at the end of our equation. And these are the two equations that we have to work with. So the way that I do this, and it's probably gonna be less interactive than in class because you can't just jump in and interrupt me unless you want to, and that's okay. But so here, look at the first equation and look and see what it has that we want. So it has 2 hydrogens. It has 3 hydrogens, so we're on the right side. It has oxygen that we don't need, and it has waters. Okay, so these things are in the correct position, but they don't have the right numbers. So there's a couple of options here. What you can do is, I don't prefer this method, but we're gonna have to multiply at some point. So I like whole numbers, so I'm gonna multiply this whole thing, including this. So if we have 3 and 2 and we want them common, this needs to be multiplied by 3, and then this needs to be multiplied by 2. So when I do that, I'm gonna get 6, 2, and 6. Again, I like to rewrite these equations. So if I multiply this, that means I have to multiply this by 3. Let me pull out my calculator. Here's my calculator. So 3 times negative 483.6. Negative 1450.8. So negative 1450.8. So you can go ahead and make that a 6, make that a 3, make that a 6. Hopefully that helps. Now, let's look at this one over here. We have oxygen and we have O3. Well, we want these, but we need it to be in the other order. So again, the way that I do this is I rewrite it, 2O3 going to 3O2. And if you remember, when we reverse the reaction, we have to change the sign of our delta H. So instead of this being positive 285.4 kilojoules, we're going to rewrite it, and it's going to be negative 285.4 kilojoules up there. All right, so now that we have done that, and let's mark all of this off. Let's see where we are, and let's see if we got it right. So here we have 6 H2s, no H2s anywhere else. 3 O2s. Oh, nope, O2s are gone, so we don't need those. That's a good thing. We have 6 waters. Can I make the screen brighter? I'm not sure if I can. Let me, I don't have an additional light. I can try to zoom down a little bit more. Hopefully that's a little bit better, but I'll have zoom on my YouTube videos too, so don't worry. But I've canceled out my oxygens. Here's my 2 O3s, and then I have 6 waters. So there, I'm good. Now, let's add these up. Negative 1450.8 minus 285.4. Or you can say plus negative. All right, so here we have negative 1736.2 kilojoules. All right, now here's the tricky part when you end up having to multiply up at the top. This that we got here, this 6, is not the target. The target is 3, 1, and 3 coefficients. So when we multiplied up here, we have to divide when we finish. So now we need to divide all of these by 2, which means we have to divide our delta H by 2. So that gives us 3H2 plus O3 and 3 waters. So you take your delta H and you divide that by 2, and so you get negative 868.1 kilojoules. That's the final answer. Now, some of you might prefer this other method, and the other method is to use fractions. I don't tend to like fractions, but some people prefer to work these problems where they look at this first equation and say, well, instead of multiplying both of these, I'm just going to multiply by 1.5, and that works. And some people say, well, instead of rewriting this and making it backwards, I'm just going to multiply by -1. I tend to get confused doing that, but that is a method that is allowed. If you like it, then do that. But I find that I make fewer errors when I rewrite things. It does tend to take me longer to do them, but I make fewer errors. So key take home from here, if you end up multiplying you up at your target, you have to divide at the end. So you have to remember to do that. If you're doing the wonky decimal multiplication method, you don't have to do that. But that is a personal preference. You do what makes the most sense to you and your brain. So I have a Hess's Law practice sheet. It is posted on Blackboard. There's 5 problems. It looks like this, Hess's Law worksheet. Now, there is not near enough room on this paper well, not for me anyway, the way that I rewrite things, to work this out, to do it. So if you prefer to work it out on like a notebook paper or something and then upload it, that is fine. You can scan it and upload the file, or the file also will allow you to just take a picture of your paper or papers on your phone and upload the image, and I can see it there, and I'll do a quick spot check and give you quiz points for that. So there's 5 practice problems with that, and we'll do that. That will be you'll get a quiz grade for that.